the name of Allah, the most beneficent, the most merciful. Assalamu alaikum all. I'm Umaima Naz with my group mate Roshan Ali. We are going to present on smart home automation using IoT based sensing and monitoring platform under the supervision of Dr. Abdul Aziz. The contents are introduction, in which we'll introduce about home automation and IoT. Literature review, that what is done by others on the same project. Problem statement, that what are the problems faced by them after designing their project. Methodology, in methodology we'll discuss the method we followed in our project. Comparison of hardwares and softwares we have used in our project. Results of our project, conclusion that we have made after designing the project, and future work that we are planning to work in future. And in the end, there are references we used in our project. Introduction. Home automation refers to electronic control of household features and appliances either manually or by the single touch on the smart application. Single touch on the smart application means there will be an application on smartphone. We will touch on the button embedded in that smartphone, and by touching the button we will control and monitor our appliances. In simple terms, it means we can easily control the utilities and features of your home via the internet to make life more convenient and secure, and even spend less on household bills. As we know that when we left our appliances turned on, it will be cost. Under the umbrella of IoT, the home automation is the best ever growing application in the modern era. Actually, IoT connects the applications or the appliances with the humans, and it communicates. It is the communication channel between the appliances and the users. Almost every task of daily routine is directly or indirectly related to smartphones. So it would be beneficial to create interaction between users and implemented systems. As we know that we are dependent on our smartphones, everything is embedded in it. Our camera, our calculator, each and everything is on our mobile phone. So why not to connect our appliances with our Android phones? We have connected our appliances with the Android application. Literature reviews that in the paper of 2017, students designed a system in which they used the already designed server, and they only connected their appliance through internet and controlled them via the purchased application. Means they used the purchased application and already designed server in their proposed system. In the paper of 2016, students designed a system with GSM module that also proved to be very expensive. It means that their project was really very expensive to use by the users. In the paper of 2015, the students designed the automated system which can only be accessed with the range of Bluetooth signals, and we know that after that range we will lose the our control over appliances. Problem statement is that Bluetooth and infrared based systems with very short range and inadequate range of accessibility. We know that after that limited range of Bluetooth, we lose our control on our appliances. Unavailability of access after a defined range proved to be expensive if appliances left turned on. It means that if we left our appliances turned on, it will be very expensive on our household bills. IoT based automation, automated smart homes with very expensive installation. As I told in the literature review, the existing systems are very expensive, and as a Pakistani we are average people, so that we cannot afford the expensive installation. This is the methodology we followed in our designing our project, that we have designed a user-friendly mobile application using MIT App Inventor that is connected to the ThinkSpeak and internet. Actually, mobile phone is connected to ThinkSpeak over internet, and it is a bilateral communication between application and ThinkSpeak, and the ThinkSpeak connects with the Node MCU. Actually, Node MCU is the gateway of our appliances and our application. Node MCU is actually sensor is connected to the node MCU, and we take the data of sensor, and node MCU send the data of the sensor to the ThingSpeak server, and ThingSpeak saves that values, and when the user want to monitor that values, the ThingSpeak will send those values to the Android application. And node MCU is also connected to the relay module, which is used to control our appliances. Actually, when the user wants to control the appliances, there are buttons embedded in our application. When the user click on that button, the control command will send to the ThingSpeak server. ThingSpeak server will then send that command to the node MCU, and node MCU will ask the relay module to turn on and off our appliances. Now the rest will be told by my groupmate Roshan.
To continue our presentation, let me once again briefly explain how this entire project works out there. So first of all, there are a couple of things that we need to explain first. One is a Node MCU. Node MCU is a hardware device, basically Arduino based programming, and other is the internet IoT. I mean, we are using ThingSpeak, a cloud server, which is basically a gateway between these appliances and our application. The first and foremost thing is MIT based home application. The application is designed in block based coding, that is the correct versions, and other things are just the appliances and the sensor. There's we need to understand what are the hardwares that are basically used in project, so that we are able to control our appliances easily. So the first and foremost thing is node MCU, the most important part of our finally project, and the second one is a relay, that is a hardware. We are using a 4-channel relay module, and the third thing, as you saw in the previous picture, was LM35, that is a temperature sensor through which we are getting the temperature, through which we are monitoring and sensing our environment. So move ahead, please. If you can see here, there are a couple of things that are included in the hardware portion. This is a 4-channel relay module, and these are 2 node MCU, and this is our temperature sensor. And we are getting the data and sending it to the ThingSpeak server. If you can see here also, we have installed this project as in ME Research Lab. So we will be having the demo of our project. So in the next portion, but till now we are moving ahead to demonstrate our project first. So whatever the hardware and softwares are used in our project, we are going to demonstrate it one by one. The first and foremost is Arduino IDE. As I discussed before, that Node MCU is purely influenced by the Arduino. It uses the platform of Arduino IDE, but the differences of architecture, and there is a built-in Wi-Fi module. There are a little bit more differences that we will be discussing in the later slide. Fine, go ahead. The second platform that we have used in our project is a MIT App Inverter. This is an online website, and this is a correct version of our coding. And if you can see that all the coding is on the block-based coding. This is a ThingSpeak link that we provided just to show the graph on the LED. These are a couple of codes that we have incorporated in our presentation, so that we can briefly explain how the things work. The third thing, as I told before, the third platform that we are using is we have ThingSpeak. ThingSpeak is basically online cloud that provides us a free access of a couple of appliances, and free access of free monitoring of the environment. Now, it does not only provide the numerical value, but also graphical values. If you can see here, these are the graphs. These dots show the current temperature of the room wherever it is installed. I mean, ME Research Lab 504. Why we choose Node MCU or other Arduino, why we choose the ThingSpeak cloud server, why we choose MIT application, why not Android application. So there is a little bit comparison between different things, why we choose specified hardwares and softwares in our project. There are a couple of reasons that I need to go in depth of. The first thing is Node MCU. Why Node MCU? Why not Arduino. If you can see, there are three things: built-in Wi-Fi module, of course. This is a no interfacing required. In Arduino, we need to interface with the Wi-Fi module first, and then to the other things. And then this is one of the best thing, is cheaper one. As discussed in the first introductory slide, that we are more focused on our price expenses. So that's why this is one of the best thing, is this is cheaper one. This is expensive one, interfacing required, more interfacing, I mean, and without a built-in Wi-Fi module. That's why we have to Node MCU. The second thing is ThinkSpeak. Why ThinkSpeak? Why not other cloud servers? ThinkSpeak, because of the three main reasons we have chosen ThinkSpeak as our cloud server. The thing is, it is easier to use. It's a free access for up to 4 channel, 32 devices. 32 devices is not a joke here. So that's why we have used our free 4 channel 32 devices for ThinkSpeak. Now the third thing, the best thing of the ThinkSpeak is a rich graphical interface. It has a very rich graphical interface in terms of graphs of the temperature, in terms of graph of our LEDs, in terms of everything. I mean, whatever for the free access, we have used this ThinkSpeak. As far as the on the counterpart, if you can see that the Blanket server is also there. That provides a little bit free access, but as far as these points are concerned, this is a little bit difficult than the ThinkSpeak. This is having a paid access up to 710 per year, unlimited graphical, and comparatively it has a poor graphical interface. That's why we have choose our ThinkSpeak. As far as the application design is concerned, we have choose MIT app inverter. Why MIT app inverter? There are a couple of reasons. The first and foremost reason is less complex. This is a really easy to use, and other is it contains a visual programming. It does not contain like old trains. We need to sit all the day and keep on writing the codes. So MIT App Inverter provides visual programming, and this is a block-based coding. Why not Arduino Android Studio? It is a complex, time-taking, and and Java-based coding. To understand the Arduino Android Studio, we need to first revise the entire Java, and we need to have a command on the Java. Then we will be able to understand the Android Studio, and this is time taking, this is complex. That's why we have choose another way, that is MIT app application, to design application in our project. So if you can see in results, there are a couple of screens that we have shown, so that we can give an intro of how our application works. If you see the front page of our application, this is the front page. You need to insert your username and password, and just after logging in, you will have this screen. This is the main screen. If you can see first, this is the corridor, streets, guest room, and drawing room, and kitchen. This type of interface you will show on our application. As far as the graphical interface is concerned, if you can see how rich the ThinkSpeak graphical interface is. This is the temperature graph. We are showing it on application. This is the LED graph. How rich you can see. If you will even click on any of the dots given here in this graph, you will get the entire data, where it was inserted, when it was inserted, when the data was interrupted. And this is the main graph in which all the appliances and the temperature sensors are included. Above all, if you can see, even we can monitor this temperature sensor and any LED graph on the spot. If you will click on this link, this is provided by the ThinkSpeak, you will directly jump to the temperature sensor graph. And if you will click on this on the counterpart LED graph, this is again the graph of the LED. But if you want to access our application right now, without wasting time, you can scan this code and you will have application in your mobile phone. Go ahead. Conclusion: why? What was the need to carry out our project? There is a couple of reasons, of course. In the conclusion, I will be telling you why we choose this project to carry in our FIP. As we brought up the idea to extend the accessibility of appliances, so we can control them from the worldwide. Previously, the work was entirely based on the Bluetooth, GSM, even was on internet, but we were determined to extend this, the range so that we can control it over the over the globe. So, by using Node MCU and ThinkSpeak cloud platform, we are making it possible. No matter how far we travel, as long as we have internet access, we can send a command to our appliances. That's our conclusion. And if we talk about the future work, in future work, currently we have installed a project in ME Research Lab 505, Academic Block 3. We aim to extend its horizon into the entire Block 3 and then to the entire university, of course, because we are determined to do it. So in after future work, we have references from wherever we have collected a little bit, even a little bit contribution of each website. We have put it here so that we can give them credit of what they have done so far.
Listening, this was all about our proposed project, and we are determined to conclude the project as we have as he has described you, and the future work we will be carrying on after this after the completion of our proposed project. Thanks for listening.
Thank you. To understand our project's methodology, it is very necessary to understand this block diagram of how our project basically works. So the first and foremost thing in our project is our application. This is MIT based block based coding application. This application has to interface with the ThinkSpeak through they will interchange the data. I mean to say that they will share and receive the data from one another. The second thing in our project is ThinkSpeak and that we need to access through internet. ThinkSpeak, what we say basically do, we will create a channel in the ThinkSpeak server which will enable us to save our data of our sensor, I mean the data of our LED, etc. Whatever the data we will be having connected to the appliances. The next thing that enable us to communicate between our appliances and ThinkSpeak is Node MCU. You can see here through the cursor ESP8266. This is Wi-Fi built-in module Node MCU. I mean to say that this is a Arduino second version that actually helps us to connect with the ThinkSpeak. So and other with the ThinkSpeak, you can see that we will at first connect our relay module to the appliances so that we can convert our 12 volt into 220 volts, and then you will see that there is a sensor. The communication between node MCU and the multiple sensors will be only one-sided. We will only get the data from the sensor. That's it. We will not send any command to the sensor. That's why the communication between these two devices would be always one-sided. So this is how our project works. Now move to the next position, how the project is actually implemented with the real-time results and graphs. As discussed in the blocks of our FYP, we were using 2 to 3 different platforms to control our appliances and getting the values of the sensors and the ThinkSpeak. So before I demonstrate my hardware, how the things work, I need to explain a couple of things about the ThinkSpeak. We have a ThinkSpeak channel. If you can see here on this, we have a temperature sensor value, one channel in which we have incorporated two fields. One is a temperature sensor and other is a LED graph. If you can see here, we are getting different values right now. If I click on this point, I will get the values of when it was inserted. If you can see in temperature 22.6 right now here in the research lab, the data is being entered right now in 8:11 and 8 a.m. We are getting the same data of the things speak on our application. If you can see, application is open right here. If I click here on the temperature value, we are getting the same value 22.58, and here is the round of 23 temperature value. And if I want to get this graph on my application, if I click on the temperature graph, uh, I will have a same graph of temperature right on my application. If you can see that this is the same graph of ThinkSpeak that is being used on this cloud server, and the same graph is also shown on our application. This is what how temperature sensor is getting data from the node MCU first, and then to the ThinkSpeak, and from the ThinkSpeak we are getting the data to the ThinkSpeak to our application. In other terms, if I see that if someone is not able to understand how the graph works, it will give the data of the real time digital value in terms of 23. This is a numerical value which makes us understand what is the real temperature of our room. The real temperature, yeah, this is 23 right now, and we are still getting the data of this temperature. If I little bit go in a depth of this graph, the difference between these dots, the different two readings is of 15 seconds. This 15 seconds is because ThinkSpeak allow us to get the data of every 15 minutes, so that it can store it and then to show it on the application. So this is all about the temperature first. Now we are moving ahead for the LED demonstration. We are going to demonstrate our LED, how our project actually works. Now we have Android application that we have designed in MIT application, and the second thing is we have this graph of our LED, when it will be closed, when it will be on. All the required data is being inserted here on the cloud platform. This is being uploaded right after we click on our application. So if you can see the LED, that LED which is fixed in, which is installed in basically ME research lab, we are controlling it basically. So if we, as I will pass the command from this node from application, I will get this change. If I apply right LED off, as I click the button, you will see that the graph will go down and the LED will turn off. Within a couple of seconds, I mean, it will take a little bit second because of the internet connection. LED is now off, but the graph is yet to turn down. Within a couple of seconds, there, see the graph is right here in the zero position. It means the LED is off. If we click on this graph dot, we will see that the LED is now off. And when the command was given to the LED, the command is given on Thursday, November 19, 2020 at 11:54 GMT 5 in Pakistan time. So this is all about the demonstration of our project. Uh, and this is how we are going to carry it out in entire block first and then to the university. Thanks.